Today we're going to discuss about the introduction of terms and microstates. So what are the terms and how they comes from the electron configuration and from the terms how the microstates will be produced. Terms, states, microstates, what are the sequences to get the microstates today we're going to discuss in this video. So, first of all, the term. What is a term? Generally, the term is an energy level of an atomic system specified by electron configuration. The term is nothing but an energy level from the electron configuration. So, generally, the electron configuration is the information from the electron configuration is not enough to get the total information about electron spectra of the molecule. So that we're going to study the energy levels from the electron configuration. So based on the information about the energy levels of the electronic configuration, we will get the electronic spectra. We will interpret the electronic spectra of the molecules. So generally, the electronic what is an energy level actually? In an atomic system, from an electron configuration, if an electron excited into higher energy level, then the energy levels will split into two energy levels, right? So electron configuration will split into two energy level, lower energy level and the higher energy level. This energy level is said to be the term. Got my point? So the term is an energy level of an atomic system. So generally in an electronic configuration, the three types of shells will be there. Completely filled shells, or unfilled, that is vacant shells, or partially filled shells, right? So in completely filled shells and in vacant shells, there is no interaction between the electrons, right? So in completely filled shells, saturation is there. There is no interaction. There is no transformation of electrons from one orbital to another orbital. In vacant shells, there is no electrons, therefore there is no interaction between the electrons. But where the interaction is taking place, in partially filled shells, the interaction between the electrons will takes place. So while the interaction is taking place, it's subject to some disturbance, that is called the perturbation. The perturbation between the electrons. So the in partially filled shells, the two types of perturbations will take place. One is inter-electron repulsion and the other one is spin orbit coupling. So what will happen? The electrons in between the partially filled shells, the transforming of electrons from one orbital to another orbital will take place. So the inter-electron repulsion will be takes place. This causes to the splitting of electronic configuration into different energy levels, and the coupling of spin angular momentum and the orbital angular momentum will give the perturbation for electronic configuration to split into different energy levels. So generally the electron configuration will split into terms due to inter-electron repulsion, and the terms, this is higher next level of generally in lighter atoms, that means the atomic number less than 30. In these molecular systems, what will happen is the electron configuration will split into terms, that is energy levels, due to inter-electron repulsion, and the terms will split into states, that is next level of energy levels. So terms will split into states due to LS coupling or Russell-Sander coupling, that means spin orbit coupling. and the states will split into microstates. This is next level of energy levels due to Zeeman effect. That means by applying of electrostatic interaction, the states will split into microstates, where these microstates are non-degenerate energy level. That means no further splitting of energy levels from the microstates. That means this is the last level of splitting of electron configuration. So, in heavier atoms, what will happen is the heavier atom means Z greater than 30, the atomic number greater than 30. The electron configuration will split into terms due to spin orbit coupling, LS coupling, or it can say it as JJ coupling. That is nothing but spin orbit coupling. And the terms will split into states due to inter-electron repulsion, and states will split into microstates due to Zeeman effect, where microstates are non-degenerate energy levels. So here one question may appear: why in Z less than 30 the electron configuration will split into terms by inter-electron repulsion? In Z greater than 30, the electron configuration will split into terms due to JJ spin orbit coupling, because while the atomic uh, number is increasing, what will happen? The size of the atom will be increases. So therefore, the magnitude of inter-electron repulsion will be decreases in case of heavier atoms, so that the inter-electron repulsion effect will be decreases in heavier atom, so that the effective disturbance, that is the effective perturbation in heavier atoms, is spin orbit coupling. Therefore the electron configuration will split into terms due to spin orbit coupling. Then the terms will split into states due to inter-electron repulsion, and states will split into microstates due to Zeeman effect, where the microstates are non-degenerate energy level. And the calculation of microstates, how to calculate the microstates, what formula to follow to calculate the microstates, we'll see in next video.